Hi students, in this video we will continue with our learning on chemical bonding, and we will be looking specifically at worksheet 2. So as usual, we will do corrections together, and please do take out your green pen and do your corrections accordingly as I go through the answers together with you. Okay, let's have a look at worksheet 2. Okay, so worksheet 2 is mostly on covalent bonding. Okay, a bit of ionic here and there, but yeah, it's a mixture of the both of them. Okay, question 1. State the type of bond formed between the 4 questions. So for chemical bonding, we only learn 2 types, right? Ionic and covalent. Okay, this is for combined science. So for ionic, if we do a quick recall, it is uh, a type of bond that forms between a metal and non-metal. Okay, specifically cations and anions. And then covalent, it happens between non-metal and non-metal. Okay, so if you have this particular understanding and concept, then question 1 is really super easy. Okay, so part A, nitrogen and oxygen, they are both on the right-hand side of the periodic table, so it's covalent. And then aluminium and phosphorus, it forms an ionic bond because aluminium is metal, phosphorus is a non-metal. C, silicon and oxygen, both are non-metals, so they form covalent bonds. D, magnesium and bromine. Magnesium is a metal, bromine is a non-metal, so they form ionic bonds. Okay, very straightforward. Next, question 2. You are given a diagram that represents a molecule of methane. So at this point, you should already know what is the chemical formula of methane, right? We have seen this in our earlier chapter, right? So methane is CH4. Okay, so when we go to Sec 4 and we learn organic chemistry, methane will be something that's very familiar to you by then. Okay, so let's look at part A. Is methane an element, compound, or mixture? Okay, so again, you should know this already. Methane is a compound. We know this from chapter 4, right? Elements, compounds, and mixtures. Because in this case, we have carbon as well as hydrogen, okay, chemically combined together in a fixed ratio, 1:4, so it's a compound. And then part B, draw on a diagram. Okay, so at this point, I just want to remind you again, you need to really read the question, and then as you go along, you need to highlight and annotate. Okay, because you really need to follow the instructions. The question requires you to draw on the diagram, so please do not copy another molecule of methane and then draw at the blank space here. Okay, that's not needed. Okay, so you need to use an arrow labeled B to show the position of a carbon atom. So carbon atom is right here in the middle, as you can see my laser pointer, right? So CH4, so this is C, carbon in the middle, surrounded by 4 hydrogen atoms, okay? Yeah, so label using an arrow labeled B, right, to show the position of a carbon atom. Okay, so draw an arrow, then put B there. Okay, simple. That's part B. Let's look at part C. Okay, C part 1. What type of bond is labeled A? Okay, so again, if you understand that methane is a covalent compound, then it becomes very easy, right? Obviously, covalent compounds contain covalent bonds. All right, so yeah, again, if you break it up, carbon is a non-metal, hydrogen is a non-metal, so they form a covalent bond. Okay, so covalent. Part 2. What does this bond consist of? Okay, so these 4 that I highlight over here, these are the bonds, right? And these are covalent bonds. So part 2 asks you, what does this bond consist of? Your answer will be, it consists of a pair of electrons. Okay, so remember, if we go back to the understanding of dot and cross diagrams, right? So maybe you might before this lesson, maybe some of you might be wondering, why do we need to draw dot and cross diagrams, right? It's really to help us see the structure. Okay, so going back to our knowledge on dot and cross diagram, so carbon is 2.4, hydrogen is 1, right, in terms of electronic configuration. So how would you draw your dot and cross? So in this case, I'm just going to draw the valence electrons, okay, just to keep things simple. So again, you need to make sure that your chemical symbols are correct. You need to make sure that the electron shells, the valence shell, they are overlapping, okay, and then you put in your electrons, right? The cross representing, let's say, hydrogen, electrons from hydrogen, and then the dot is electrons from carbon. So can you see the contrast here, the comparison here? So the cross and dot make up one bond, another one bond, and then this one makes up this bond, and then finally the last one makes up this bond. Okay, so that's why in each covalent bond, in this case, represented by one line, this is it consists of a pair of electrons. Okay, we will move on to the next question. Okay, let's continue with question 3. Okay, let's scroll down. Alright, so question 3, you have an element called Y, which has the electronic structure of 2.8.4. So part A, you're supposed to suggest a chemical formula of the compound in which this particular element forms with chlorine. Okay, then after that, you need to draw a dot and cross diagram of the structure of this compound. Okay, so yeah, so this question, right, you realize actually there's two parts to this question. Okay, so part one that you need to address is the chemical formula of the compound which forms with chlorine, the element that forms with chlorine, and then part two you need to draw dot and cross diagram. Okay, so in the case where questions are phrased in this way, just take note lah. Okay, so annotate and make sure that you don't miss out any points. Okay, so element Y is 2.8.4. Okay, so maybe now let's bring out the periodic table again. Okay, so periodic table is your best friend, right? So you have to refer to it for sure. So yeah, so based on what we already know, okay, so over here we can tell that it has 3 electron shells. So meaning element Y can be found in period 3. Okay, so period 3, so it can be either of those elements highlighted, right? So the next piece of information that we know is that element Y has 4 valence electrons. Okay, 4 electrons on the valence shell. So from that info, we know that Y belongs to group 4. Yeah, so based on this method, right, obviously we know that element Y is silicon. Okay, so silicon, the chemical name, the chemical symbol is Si, and it's 2.8.4. Okay, so hopefully, really, if by now you still don't know how to use this trick, right, hopefully this is very, very clear to you. Okay, so back to the question, you need to suggest the chemical formula of the compound which this element, which now we know is silicon, forms with chlorine. Okay, draw a dot and cross diagram of the structure of this compound. Okay, so if we look at silicon, right, we know that it needs 4 more electrons in order to obtain stable octet electronic configuration, and chlorine needs 1 more, right? 1 more because now it's 7, it needs 1 more to form octet. So you realize that this actually looks very similar to our previous question, which is methane, right? So for example, carbon is 2.4, hydrogen is 1, right? You do notice carbon, because it's 4, again, it needs 4 more to become octet, and then hydrogen needs 1 more. Sorry, here I wrote wrongly. Okay, then therefore the compound form is CH4, right? So based on that understanding, okay, you can bring your understanding to this question as well. So straight away you'll know that the chemical formula will be silicon tetrafluoride, so SiCl4. Okay, because the way that the electrons bond is similar to what we saw in methane. Okay, and if we do a quick check anyway, silicon and chlorine both are non-metals, so not an issue, right? It's correct, it forms a covalent compound. Okay, so now let's do the second part of this question, which is to draw the dot and cross diagram. Okay, so I got no space, so I shifted a bit. Okay, but yeah. So we do the same things, right? We always start off with the atom, which is silicon 2.8.4, chlorine 2.8.7. Okay, so we always look at valence electrons only, right? So silicon, it has 4, then chlorine has 7. So we need to keep that in mind. So as we draw the dot and cross diagram, okay, so first step is always draw the chemical symbol, and then after that you draw in uh the valence shell, and then make sure that it overlaps, right? For covalent bonding, you need to make sure that it overlaps. Okay, so this is what I'm doing right now. So generally, we should try to make sure that the circles are the same size for the same atom. Okay, but of course, we are not doing precision art right here, so it doesn't have to be super precise, but try as much as possible, okay? Then after that, write in the legend, okay? So a cross would represent the electron of a silicon atom, dot is that of the chlorine atom, and then after that, you just draw in all the bonding electrons, okay? Dot cross, dot cross, dot cross, dot cross. Now, if you just leave your answer like this, it is only worth 1 mark. Okay, so think about it. If you pause the video, you're going to think about it. Why is it wrong? Okay, why is it only 1 mark? Okay, so once you come back from pausing the video and thinking about it, okay, so let me remind you what are the things to take note of again. So number 1, again, because it's called dot and cross diagram, you need to draw dot and cross. Okay. Next, for covalent compounds, you need to make sure that your covalent bond is there. So each covalent bond is just like what we saw in the previous question, right? Each covalent bond consists of a pair of electrons. One from one of the non-metal, the other electrons from the other non-metal. Okay, and then thirdly, most importantly, you need to make sure that it achieves a stable octet electronic configuration. Okay, so you realize that it actually looks very similar to when we drew ionic compounds, right? The only difference is step number 2. Instead of drawing square brackets and charges, now we are looking out for these covalent bonds. Okay, the bonding electrons. So how to make this into a full mark answer basically will be to fill in the remaining electrons that belongs to chlorine, right? Earlier on we saw that chlorine in its valence shell it has 7 electrons, right? 1, 2, 3, 4, 5, 6, 7 ma. Okay, so yeah. So this is really just to demonstrate to you that this is a very common mistake that students make. Yeah, because they will, do the question and then happy think that they are done, but they forget to make sure that it is a stable octet. Okay, so hopefully you got that part. Okay, so now let's look at part B. Alright, compare and contrast the boiling point and electrical conductivity of this compound with those of sodium chloride. Okay, so this compound is SiCl4 as we have just drawn in a while ago. And then sodium chloride is NaCl, right? We have seen that many times by now. Okay, so after reading this question, right, immediately you should be able to appreciate and understand that here we are trying to compare and contrast the two physical properties, which is boiling point and electrical conductivity, between covalent compounds and ionic compounds. Okay, that is the basic understanding that you need to be able to achieve first before you even plunge into answering the question. Okay, and since this is the first time that we are doing this, so let me just type out the answers for you to see first. Okay, then we will run through it together. Okay, so this compound, SiCl4, it has a lower boiling point than sodium chloride. Okay, so you need to ATQ first, right? Answer the question. And then you go on to say that sodium chloride is an ionic compound, okay, with strong electrostatic forces of attraction between the ions, okay, which requires a large amount of energy to overcome. All right. So you have your ions, right? So you have your Na plus, sodium cation, Cl minus, chloride anion, okay? Then it's a plus and a minus. So when they come together to form a compound, the ionic bond, right, is a very strong electrostatic force of attraction. between the two ions. Okay, so it's just like how if you want to, okay, maybe let me pause this for a bit. If when you want to, let's say, melt salt, right? Sodium chloride is common table salt. If you want to melt this solid into liquid, right? Even if you put it under the Bunsen flame, under Bunsen burner for very long, you need to heat for very, very long in order for your sodium chloride solid to start to melt. Okay, so if you look at things at the micro level, which is what we are studying for chemistry, then you will realize that, you know, there's this strong electrostatic forces of attraction between the ions. Therefore, on a more macro scale, when you want to melt your salt, it is very difficult. It requires a large amount of energy to overcome. Okay, okay, then going on to the covalent one. Okay, so the covalent compound, on the other hand, is just a simple covalent molecule, okay, with a simple molecular structure, with weak intermolecular forces of attraction between the molecules. Okay, so this requires only a little amount of energy to overcome. Okay, so since we uh so for our three classes, right? 3 and 3, 3, 3, 3, 4. We have gone through ionic bonding quite extensively already. Okay, but covalent bonding was only the previous lesson. So let's talk about this a bit more. Okay, so if you were to look at me on the little screen, okay, I'm gonna do some demo, so to speak. Okay, so you remember this, right? You remember what this is? Okay, I'm gonna assume that I hear you saying water. Okay, even though this is quite silly because I'm really talking to myself, but okay, water, right? H2O. If you look at can you see my Apple Pencil? Yeah. Okay. So this this well, I cannot multitask. This red color sphere, okay, this is oxygen, and then the two white color smaller ones, those are hydrogen. Okay, so that's why you have a H2, 1, 2, and then one oxygen, H2O. Okay, and like I said, some of you might know this in primary school that this looks a bit like the Mickey Mouse shape, right? And yeah, so this is the shape, right? Band shape. And the thing about water is that, so water is just like SiCl4 in this case, right? So it is a simple covalent molecule, okay, with a simple molecular structure. Okay, so now remember, okay, so at this point, if you are confused or you would like to revisit this part on covalent bonding, I suggest that you really just pause this video, open another tab on YouTube, and go and view my covalent bonding lesson again. Okay, and then once you're comfortable, you come back and then we continue with the discussion. Okay, all right, so this is water molecule. Okay, so we said that because it's made out of oxygen and hydrogen, right? And oxygen and hydrogen, they are both non-metals. That's why covalent bonding is involved. Okay, now if you look very closely over here, okay, the gray color thing, right? That one is the covalent bond. Okay, so and as we have mentioned, covalent bonds are very, very strong. Okay, so why would we then your next question might be, why would we say that water has a very low boiling point, right? So for example, water, as we know, boiling point is 100 degrees Celsius, right? Which is not very high. Okay, so the confusion really usually sets in this way, right? Students will always confuse, how come you say covalent bonds very strong, but then the boiling point of covalent compounds are so low? Okay, now you really have to know this difference. So okay, so here now I have two, right? I have two water molecules. Okay, okay, so covalent compounds, sorry, the covalent bonds is the gray color thing, right? Whereas over here, if you now look at my mouse here, right, weak intermolecular forces of attraction between the molecules. Okay, this thing has nothing to do with covalent bond. It's totally different things. Okay, so covalent bonds is what is within the molecule, okay, within the molecule. Whereas the weak intermolecular forces of attraction is between the molecules. So meaning there are some weak forces of attraction that is holding these two water molecules together, okay, in place. Yeah. It's very English, like, I mean, intermolecular, between the two molecules. Okay, it's just like how we have interclass competitions is between classes. So weak intermolecular forces of attraction is just the forces of attraction between molecules. Okay, very different from covalent bonds. So in fact, I can do a demonstration here, right? You see covalent bonds. If I want to break this water molecule up, right, back into the uh, hydrogen and oxygen atoms, I will have to do this. Okay, can you see that? Then it becomes oxygen, hydrogen, and hydrogen, H2O. Okay, and you realize just now that movement, right, is like suggesting that it requires a lot of energy, a large amount of energy to break them up, to overcome the forces of attraction. Get what I mean? Yeah, okay. That took a bit long. I need to pause this before my computer goes crazy. Continue, shall we? So, okay. So we have addressed the first physical property, which is boiling point. So in the next paragraph, we shall talk about the second one, which is electrical conductivity. Okay, so this compound, which is SiCl4, is unable to conduct electricity in any state. Okay, so being a covalent compound, it cannot conduct electricity in any state, meaning solid, liquid, or gas. Okay, and then what is the reason? Because there is no free moving ions or electrons. Okay, on the other hand, sodium chloride can conduct electricity in both the aqueous and molten states. Molten meaning liquid lah. It's like how molten lava is basically just the liquid state, the flowy state of your whatever that comes out from your volcano. Okay, and that is because of the presence of free moving ions, right? Because sodium chloride is an ionic compound, so it has free moving ions in the aqueous and molten state. Okay, so this is the answer. Okay, but of course I'm not going to leave you over here just like that. Okay, let's look back at the question. Okay, so it says compare and contrast, right? Now, if you are okay, so I'm also a humanities teacher, right? So let's bring in some humanities skills into this question. So compare and contrast is very much like comparison like that, right? Similarity and differences for source-based question. So if you look at my first paragraph, right, the first line basically is like your point lah, right? Your ATQ. You answer the question, okay, by saying that the covalent compound has a lower boiling point than the ionic compound. Okay, in this case, they tell you it's sodium chloride. Okay, so here I'm going to do like a lot of color annotation so that it's very clear for you. So sodium chloride, okay, is an ionic compound with strong electrostatic forces of attraction between ions. Okay, so that's the first important part. All those underlying parts are very important. Okay, yeah, between ions, because again, it is an ionic compound. The ionic bond is between the ions, right? Cation and ion. Okay, then go on to address the issue here. So therefore it requires a large amount of energy to overcome. Okay, then now we talk about the covalent compound. Okay, so this compound, which is SiCl4, on the other hand, is a simple covalent molecule. Okay, then in terms of structure, it has a simple molecular structure. Okay, and thereby it tells you that it has weak intermolecular forces of attraction between the molecules, right? Just as what I've shown you just now. Okay, this one has already been broken into pieces, but you get what I mean, right? Weak intermolecular force of attraction between the molecules, which requires just a very little amount of energy to overcome. Okay, yeah. So can you see that? So it's like point, example, and then explanation, right? I mean, if you want to do it in a very humanities kind of way, point, PEE, right? Point, example, explanation, and then again for the covalent compound in this case also same. Example, explanation. Okay. All right. So we are done with the first physical property, which is boiling point. Now let's look at electrical conductivity. Okay. So you have only addressed one part of the question. So second paragraph, you say, okay, again, this compound is unable to conduct electricity in any state. Okay, so that's your point again. All right, as there is no free moving ions or electrons. Okay, so for covalent compound, right, this particular explanation, you need to mention electrons as well because it's not ionic bonding, right? So that's why you need to mention ions or electrons. Okay, then as for sodium chloride, the ionic compound, okay, your point will be that it can conduct electricity in both aqueous and molten state. Okay, and then what is the explanation? Because of the presence of the free moving ions. Okay, so can you see that? Hopefully this is a lot clearer and gives you a structure to kind of follow. Okay, and to really link back to this part, right? Okay, if you are very good humanities student, you will immediately spot this after I do all this. Okay, so this first paragraph is a comparison, comparing boiling point electrical conductivity of this and this. And then the second paragraph is contrasting. Okay? Yep. Okay. Next question. Okay, let's look at question 4. So we have element Y, which forms a compound with hydrogen of formula YH4. Okay. This compound has a melting point of negative 183 degrees Celsius and a boiling point of negative 161.5 degrees Celsius. So you need to state with reasons the 4 questions, A, B, C, and D. Okay, so part A, the physical state of the compound at room temperature. Okay, so at this point, you need to first know that the scientific room temperature value is 25 degrees Celsius. Okay, this one is a given. And then, so for this kind of questions, right, for my students, you would know that you should use the number line method, right? I personally feel this is the easiest. Okay, so making good use of what you learn in mathematics to help you with this. So you draw a number line, then you put in where is the melting point and boiling point, put in the values. Then you ask yourself, where does room temperature lie within this particular number line, right? So 25 degrees Celsius, where is it? It's over there, right? It's way beyond the boiling point already in this case. Okay, so then the next step is to divide this into 3. Okay, so if you are before melting point, you haven't melt, right? The substance haven't melt. It means that it is in the solid state. Okay, then if it's now in the melting and boiling point zone, as in the in-between, right? Melt already but haven't boiled, then it will be liquid. And then of course, if it's like boiling water like that, right? It has already reached the boiling point, all your liquid has boiled over and become vapor already, the gaseous state, and it's gas. So in this case, since 25 degrees Celsius is in the gaseous so-called zone, right? Then your answer will be gas. The physical state is a gas, as the boiling point of the compound is lower than room temperature. Okay, so yeah, keep in mind that you need to, the question asks you to state with reasons, right? Okay, so just describing and giving the answer per se is not enough. You need to supplement it with an explanation. Okay, then part B, the type of bonding in the compound. All right, so so if you get part A correct, B shouldn't be an issue at all because knowing that the compound has a low melting and boiling point, straight away it tells you that it is a covalent compound, right? We only learn two, ionic and covalent for combined science. Of course, pure chem, there's metallic bonding as well. Yeah, so covalent bonding. Okay. So what is the reason? State with reasons, right? So covalent bonding as the compound is, sorry, what happened? As the compound has low boiling point. Okay? Yeah, so that's one of the physical properties of covalent compounds, right? Part C, whether element Y is a metal or non-metal. Okay, so again, you realize like if you right from the first step, right, in the question, if you are able to pinpoint what concept the question is trying to test you on, then everything else flows and it becomes very easy. Okay, so knowing that it's covalent bonding, obviously Y has to be a non-metal, right? Because it forms covalent compounds, a covalent compound with hydrogen, and hydrogen is also a non-metal. It's a It's a gas, right, at room temperature and pressure. So it's a non-metal. And then part D, the number of valence electrons in an atom of Y. Okay, part D is interesting. And so again, going back to the compound, right, they tell you it's YH4. So can you see, so like really, from the start of the worksheet, we saw methane, which is CH4. And after that, we saw SiCl4. Now we see YH4. Okay, so yeah, so if you, like I said, if you understand chemistry, you do the different questions, right? Even though the question will change, but the concept remains the same. Okay, so and if you are able to spot patterns like these, then yeah, the answer is so straightforward. Okay, so there are 4 valence electrons, okay, in an atom of Y. Okay, sorry, I clicked something by accident. Okay, 4 valence electrons. Why is it so? Okay. Oh, okay. This one is, in terms of the explanation, is slightly more challenging. Okay, but I mean, even if you are unable to give the explanation correctly at the start, yeah, you should be getting the first mark, which is stating the number of valence electron, which is 4, right? So what is the reason? Because it forms a single, because it forms single covalent bonds with 4 hydrogen atoms. Okay, so again, just to remind you how the structure looks like. So CH4, this one is a chemical formula, right? Chemical symbol. So you can draw the structure so that you can see a bit clearer. Okay, so CH4 you realize is CH bond multiplied by 4 times, there's 4 of that. And then silicon tetrafluoride, there's again 4 of the silicon and chlorine that bond. And then finally, Y and H is also the same. 4 of them to make up your YH4. Okay? Okay, come, let's talk about question 5. Here you have a table which shows you some properties of 5 substances, A, B, C, and D. Question A part 1, which substance has ionic bonds? Okay, so if you look at ionic bonds, right? So obviously only ionic compounds can have ionic bonds. Okay, and now if you look at the table that is given to you, okay, you see melting point, boiling point, you see solubility in water, you see electrical conductivity. Okay, so again, if you go back to your notes, right, these are precisely the 3 physical properties that you need to know, right? Okay, so yeah, so if you think back to ionic bonding for ionic compounds, for melting and boiling point, they have is very high. And then in terms of solubility in water, it is very soluble in water. And electrical conductivity, for if it's a solid state, it does not conduct electricity, no. And then liquid, it does, right? The molten state, it does. Okay, so based on that understanding, we go back to the table, we just do the necessary, right? Look for those that have high melting boiling point, high solubility in water, poor conductivity in solid, and good electrical conductivity when molten. So answer is D. So that's the easy part. Part 2 is the one that requires a little bit more thought. So explain your answer, right? So basically putting whatever that I just said in words lah, okay? So D is the substance with ionic bonds because D is a good conductor of electricity when in the molten state, okay, but not in the solid state. All right. Yeah. Okay, so that's your answer. Now, okay. So if I can do some mind reading right now, okay, I would think that some of you will be like, hey, I want to ask a question, right? What if my reason I put that they have high melting and boiling point? Okay, so I'm going to address this question right now. Okay, so can you just put a star, highlight this question? Okay, so I'm just gonna give you a bit more info. Okay, so for covalent bonding, we learned that the compounds have simple molecular structure, right? Okay, so this is all that you need to know for combined science students. Okay, but for pure chem students, they actually learn something extra, which is this giant molecular structure. Okay, so a very classic example is diamond. Okay, So diamond basically is just carbon that is bonded in a different way. Okay, I will stop there. If you want to know, you can go and ask me separately. Okay, so diamond. So as we all know, diamond on our diamond rings, right? Or diamond earrings, like mine here. Okay, it has very high melting and boiling point, correct? It can withstand very high amounts of heat. Okay, so my point is because of this, for A part 2 over here, the best answer is that you talk about electrical conductivity. Okay, because if you talk about high melting and boiling point, actually, technically, covalent compounds that have the giant molecular structure, they also have very high melting and boiling points. Okay, get what I mean? Yeah. So, so in this case, yeah. Okay, but as for ionic compounds, um, if you talk about electrical conductivity, right, it's strictly that, okay? Because ionic compounds, they can conduct electricity in the molten state, but not in the solid state, okay? Because there's no free moving ions. Okay, then B part 1, which substances have covalent bonds? Covalent bond, this question is also very easy, right? I mean, okay, it's easy when you are very good with your concepts. That's what I'm trying to say. Okay, so, so for covalent compounds, one concept that you need to know is that it cannot conduct electricity in all states, right? All meaning solid, liquid, gas. Okay, so meaning how you can do this question is you look for those that have very poor electrical conductivity. So like here. That's why straight away I know the answer is B and D. Okay, everything else is immediately eliminated. Alright. Okay, so yeah, B part 1, B and E has covalent bonds. That's the easy part. So part 2, explaining your answer, right? So again, you will bring up the fact that they are poor conductors of electricity in both the molten as well as solid state. Okay? Alright. Wait for myself to write everything finish. Okay, and at this point in time, I just want to remind you, right? In the notes that I gave you, it says, if it's a very general question, you have to say that they are poor conductors of electricity in all states. Okay, but of course, to the context of this question, they only give you both molten and solid, so that's why your answer is as such. Okay, so the part on both, it's important. You should put a star. And then finally, the last question, C, right? Part C, what type of substance is substance A? Okay, so for combined science students, like I said, you don't learn metallic bonding, but it really doesn't matter. If you look at the table, right, it has high melting boiling point, it is insoluble in water, cannot dissolve in water, and then electrical conductivity, be it in the solid or molten state, it is good. It can conduct very well. So common sense should tell you that it is a metal. Okay, so this is actually lower sec science knowledge. Okay, so they give you the table already. So using the data or the information given in the table, you should be able to deduce that it's a metal. Okay? Alright, next question. Question 6. Let's look at this question. Okay, so here you have phosphorus, which has the electronic structure 2.8.5, and it forms a gaseous compound with hydrogen. Okay, so part A, you're supposed to name the type of bonds present in this gaseous compound. Now, at this point, I just want to remind you again, right? So in class, I told you before, so in exams, whenever they give you a question, right, whatever that is stated in the question, right, is sufficient and it's just nice for you to answer the question. It won't be too much such that it confuses you, like with unnecessary information. Neither will it be too little such that you don't have enough information to answer the question. Okay, so in this case, let's say it says it forms a gaseous compound, right? So that is actually a clue that you need to pick up to know that therefore the compound that's being formed has a low boiling point. And then of course another clue is phosphorus and hydrogen lah, and you know that it is both nonmetals, right? So obviously it's forming a covalent compound, so the type of bonds present will be covalent bonds. Okay. Part B, draw a dot and cross diagram to show the electronic structure of a molecule of the gaseous compound. Uh, okay, so usually, okay, like I said, it depends on the question lah. So covalent compounds, more often than not, you only need to draw outer electrons, okay? But like I said, you follow the question. So over here, I'm just going to draw outer shell electrons, okay? Okay, so go back to, again, our steps, right? So looking at the atom first, the electronic configuration is as such, right? 2.8.5, hydrogen is 1. And then using the method that I taught you, because phosphorus needs 3 more electrons to achieve octet, and hydrogen needs 1 more, right? So the sharing will be as such lah. So phosphorus will need to share 3 electrons, hydrogen will share 1. Okay, so using that kind of train of thought, you should be able to deduce that the chemical formula should be pH 3. Okay, but even if you cannot, later I'll tell you another trick again. But now let's look at the dot and cross diagram. Okay, so you draw the chemical symbol, then after that you make sure your electron shells, they overlap. Okay, then you write the legend. Okay, so yeah, legend is very important. Like I said, there's no marks given per se for legend, but you are really just doing yourself a service by writing the legend so that you are not confused. And this is especially so for covalent. Okay, so yeah, so each covalent bond is 1 pair of electrons, so dot cross, dot cross, dot cross. And then, yeah, then if you look at phosphorus, right, so the last step, okay, you're not done yet. You need to look at whether you have filled in all the electrons and whether each atom is stable. Okay, so phosphorus, you need to draw 2 more, right, in order to have the stable octet, because phosphorus itself, it has 5 electrons in the valence shell. Okay, so that's 2 marks. Smiley face, easy. Part C, what is the chemical formula of this compound? Okay, so part C is easy, right? pH 3. So at this point, let's say if you are confused or for some reason you cannot draw this during exams, right? You can use a trick again. So if you understand, like I said, you can deduce from what you already know, okay? So for instance, if you look at the periodic table for group 5, right? Because this one is 5 valence electron. So group 5, above phosphorus is nitrogen, right? Which is 2.5 because it has 1 electron shell less, right? So we have seen this before, NH3 ammonia. When nitrogen forms compound with hydrogen, it forms NH3 ammonia. So following that train of thought, and actually when we go on to our next topic, which is periodic table, it will become a lot clearer to you when we talk about periodic and group trends. Yeah. So my point is, let me just quickly wrap this up. Yeah. So um yeah, so basically chemistry is also about spotting patterns, right? So if nitrogen, which is in the same group as phosphorus, forms a NH3 kind of compound, then phosphorus, which is the fellow that's right below, should also form something similar. And in this case, pH 3, right? Because like I mentioned, if you look at bonding, chemical reactions, we are essentially more, or rather, we are only concerned about the electrons that are on the outside, the valence, right? So your ammonia molecule is going to look exactly the same as this, right? Just that the symbol in the middle changed only. You get what I mean? Okay, so yeah, so even if you are not very strong in chemistry at the start, what I suggest is you really have to be able to equip yourself with the skill to be able to spot patterns and deduce from what you already know. Okay, so and please don't give up. Like I said, chem is try. So yeah, if you try, then at least you can get some marks lah. Okay, and I shouldn't ramble on anymore because we still have some more questions. Okay, let's look at our last question. Question 7. So over here you have the total numbers of 4 elements given to you below: hydrogen, oxygen, sulfur, and chlorine. Part A, you're supposed to determine, or rather predict, the formula of chlorine oxide. Okay, so a lot of things in this question, but again, nothing to be afraid of. You just need to do step by step, right? So looking at you break it up, you break the compound up, you know that basically you're looking at the elements chlorine and oxygen. So chlorine is 2.8.7, oxygen is 2.6. Okay, so again, using the trick I taught you, Chlorine needs 1 more electron to be stable. Oxygen needs 2. Okay, so therefore you can manipulate and figure out that it is Cl2O. Okay, because you will need 2 units of your chlorine in order to bond with 1 unit of your oxygen. Okay, then part 2, you're supposed to draw the electronic structure of a molecule of chlorine oxide showing only the outer shell electron of all the atoms. Okay, so if you see this term electronic structure, right, it's actually just the same thing as dot and cross diagram. Okay, because you are showing in detail what is the structure lah, how the electrons are being put in the electron shells. Okay. Okay. So let's do the drawing. Okay, so we do chlorine. No, sorry. You draw oxygen first. Okay. In the middle, then your chlorine electron shell. Chlorine electron shells needs to overlap. Then you write your legend. Okay, so let's say cross represents electron of oxygen atom. Dot represents electron of chlorine atom. And then you draw in your bonding electrons, dot cross. And then you're not done, right? Remember, you need to check for whether around each atom they are stable or not. Okay, so for chlorine, it is octet, so you need to draw in the other 7 electrons, or rather the other 6 electrons, because chlorine has 7, right, in its valence. And then oxygen will have 6 in total. 6 in total. Okay, then yeah, you already have 2, which is bonding. Then you need 4 more. Okay, so that's done. 2 marks. Smiley face. Okay, moving on. B part 1. Predict the formula of hydrogen sulfide. Okay, so again, looking at the atoms itself, hydrogen is 1, sulfur is 2.8.6, right? Let's check. Okay, even if you're confused, question tells you sulfur proton number is 16, right? Okay, so 2.8.6, yeah, correct, 16. Okay, yeah. So again, hydrogen needs 1 electron to form duplet, stable duplet, and then sulfur needs 2 more, okay, to form stable octet. Now, at this point, I need you to again be smart, okay? Exam need to be smart. So you should relate to what you already know, which is H2O, right? Water. And since sulfur is just 1 element below oxygen, it's in the same group, so you will just basically have to, switch things up, switch your oxygen into sulfur. Okay, so your hydrogen sulfide chemical formula is H2S. So part 2, draw the electronic structure of hydrogen sulfide, okay, which is H2S, forgot to write, showing only outer electrons, okay? Yeah. So you know H2O looks like that, right? Mickey Mouse. By now, if you still don't know water looks like that, you should really, I don't know what to say, okay? So H2S will look something similar also, like that. Okay, so yeah, so this drawing is super simple, right? So you draw sulfur first, and then you draw hydrogen, make sure the electron shells overlap. Okay, and in this case, hydrogen is a lot smaller. Put your legend, cross represents electron of hydrogen atom, dot represents electron of sulfur atom. Next, you draw in the bonding electrons, because it's a single bond, so it's just 1 pair, dot cross, dot cross. Then complete the stable octet for sulfur. Alright, octet means 8, right? Think about octopus. So octet means 8. Duplet, D for double, so duplet means 2. Okay, so easy. 2 marks. Smiley face. Moving on. Part C. What would you expect the 2 compounds in part A and B to have high or low boiling points? Okay, so again, your 2 compounds. First one is Cl2O, chlorine oxide, and H2S, hydrogen sulfide. Okay, so knowing that they are all non-metals, so obviously they are covalent compounds. So covalent compounds have low boiling points. And then part D, predict two other physical properties of these two compounds, right? You only learn 3 physical properties for this ionic and covalent compound, so it's basically the other two lah. Okay, so they are soluble in organic solvents. Okay, again, when we go to Sec 4 and we learn organic chemistry, you will be able to appreciate this a bit more. Okay, and number 2 is they do not conduct electricity in any state. This is what I mean, okay? If the question is very general, like this part D, right? Then you write any state, okay? Alright. What's the time now? 12:54 a.m. Okay, that's it. That's all, folks. Smiley face. I will see you, my students, in the next lesson. Okay? Cheers. Smiley face. So anyway, just to end off nicely, this has been a video on, or rather a lesson on chemical bonding worksheet 2. Please make sure you do all your corrections. Please go back to SLS to answer my question. And oh, if you want to ask question, please post it on Padlet. Okay, then I will address it. Alright, goodbye.